Hello everyone, welcome all of you to the module Geospatial Web Applications. My name is Trí Hứa and I'm from Vietnamese German universities. Today I would like to introduce you another lesson regarding the Keyhole Markup Language, KMLs, which were a markup language was built based on XML. The content of the presentation today start with the introductions. In this introduction, I will introduce you briefly information about KML. And the next, I will show you some main KML elements we use to develop a KML file. The lookat element and the camera elements will be introduced later. And after that, a bed, a polygon, and the style of KMLs will also be discussed. And lastly, we will talk a little bit about the KMZ, that is a zip file from KML to reduce the file size of this file. Firstly, we say KML stands for Keyhole Markup Language. So as the name of the language, that is a type of markup language based on XML, extensible markup language. The KMLs were originally developed by the Keyhole Incorporations. That is a company acquired by Google later, which further developed and popularized KML to us. KML files are commonly distributed in the KMZ files, which are essentially zipped KML file, and the extension of this zipped is KMZ. The KMZ files offer the advantages of smaller the file size and easier sharing, so they can include additional research like image or 3D models alongside the KML data. KMLs use a three-dimensional graphics reference system of the longitudes, latitudes, and altitudes to describe a basic point of views in space over or on the surface of the Earth. It then adds more specific controls over that view with hidden, tilt, and drawn factors. The KML also offers the ability to add text information, graphics overlays, 3D polygon, bed, icons, and add embedded files, for example, image or auditory, to enhance the experience of the Geo browser application. Now we will see how the KML file looks like. Normally, the KML files must begin with the XML hidden information because it's were written based on XML. So you will see the XML declaration as usual here in the first line, and followed by the root KML tag. So after the declaration, the KML itself will be the root element, and the information of the root element is given here. That's the namespace of the KMLs. So in this example, we will have one KML file, and the KMLs here contain the playmark. The playmark is the child element of the root KML. So by default, KML is only the root element. And the playmark child element has some sub-child elements. For example, here we have the name of the playmark, the description, and the point. So the point of the playmark will have the coordinate. So to sum up, in this KML, it will show a playmark named Golden Bridge with the description as an iconic suspension bridge in San Francisco, and the coordinate to show it on the Geo browsers. So you will see on the right photo, or the photo in the right corner of the screen, there's one play mark word mark, and this information will be given in the balloon. This is the enlarged photos from the previous KML document. Here's the Golden Gate Bridge with the balloon show the descriptions information as well as the name of its play mark. In the given XML snippet, the XML namespace GX introduce a namespace declaration from the Google extension namespace, often abbreviated as GX. These declarations allow the elements and the attributes from the Google extension namespace to be used in the within these XML documents. And the namespace prefix GX is used to qualify elements or attributes that belong to the Google extension. For example, GX checks or GX attitude mode. The full list of the Google extensions namespace you can find on the website of KML tutorial by Google. So, to sum up, without the namespace declaration elements, the attributes elements from the Google extension would not be recognized, and it may result in basic errors and incorrect interpretation of the XML document. So, as you know, in XML documents, everything between these opening tag and the closing tag is called one element. It's content of the element. But in KML, it's a bit different. Everything is considered as one object. This means that all elements within the KML document will represent some form of graphic objects or features in real life. And the KML defines abstract elements, which are generic placeholder for different types of graphic objects or features. And these abstract elements serve as a template or blueprint for a specific type of objects. Objects in the KML are represented within XML tag. For example, the point tag will enclose the definition of a point object. And the point tag could represent a specific graphic point on the Earth surface. More advanced tags in KML, such as play mark, line strings, or polygon, are typically used to define more complex graphic features and often utilized in applications like Google Earth or visualizing spatial data. Within this figure, we can see the structures of one element, one object in the KML. For example, the objects has the geometries of point. Yeah? We will see we have different geometries information in one object. It could be point, line strings, polygon, and so on. And more than that, you can add some feature information or the style selector to that element. As we discussed before, one element in KML documents is an object, and every object has coordinate. A coordinate element within the context of graphic data typically comprise three floating point values: longitude, latitude, and altitude. Each value serves to precisely specify a point or location on the Earth's surface. You know what is latitude, longitude, and altitude. However, I would like to repeat or to explain briefly what latitudes in KML. Latitude is the value indicates the angular distance, north or south of the equators, which is designated at 0 degree latitude. And latitude ranges from minus 90 degrees, the south pole, to plus 90 degrees, the north pole, with positive value representing location in the northern hemisphere and negative values for the southern hemisphere. The longitudes present the angular distance in degree relative to the prime meridian, with base through the Greenwich in England. The longitude west of the prime meridians range from minus 180 degrees to 0, and the east of the prime meridians range from 0 degrees to plus 180 degrees. And this system allows for the precise identification of location worldwide. Altitude. The altitudes is the distance of the camera from the Earth's surface. So this value indicates the vertical distance of the camera or observers from the Earth's surface, typically measured in meters, and the altitudes is interpreted according to the altitude mode element, which I'll show you later. And altitude mode specify how altitude values should be understood or applied in the KML or in the Geo browser. And the altitude mode might include absolute altitudes measured from the sea level, or relative altitudes measured from a specific reference point, or other mode tailored to a specific application or context. We have just discussed altitude and altitude mode. Now we take a look into the different options of the altitude mode we can have. By default, when we input any value in the altitude element, that is the height in meters above the route or the level of the water body at that point. So that option is relative to route. The other option you can choose that is the climb to ground or the absolute option. With the climb to ground option, these are the altitudes exactly at the height of the terrain or sea level. And the absolute option, this is the height in meters above the sea level. So we go to the hidden elements. With the hidden elements, you can specify the rotation of the camera in the geospatial browser around the z-axis in degrees. And the values of that hidden element will range from 0 to 360 degrees. So this means a full round. 0 degrees correspond to the north and the rotations clockwise from the north. On the right picture, you can see how's the difference if you set the value of the hidden to a different degree. More than that, we have the tilt option. The tilt option is the rotations in degrees around the x-axis. So the value from 0 indicate that the view is aimed straight down toward the Earth, and is also the default option, default value. And the value for 90 indicate that the view is aimed toward the horizons. When we input the value more than 90, that indicate the view is point up into the sky. And value for climb at 180 degrees. We also have the other element, drone. The drone is the rotation in degrees around the z-axis, and the value will be range from minus 180 to plus 180 degrees. We look into this specific example with the look-at element. In KML, we have one element named look-at. Is used to define the viewpoint for the visual camera in a geospatial context. And this element allows you to specify the positions or the orientation and the other parameters of the camera to control the view when the KML file is located in viewer such as Google Earth. Now I'll explain you what do we have here. We have the specific code for KML with look at elements is used. So the look at element, we want to show the Eiffel Tower camera, the Eiffel Tower at the on the Google Earth, and we have the look at element to adjust the virtual camera. And with the longitudes, we set to longitude and latitudes, and the altitudes we define the positions of the camera. More than that, we use the hidden to show the rotation of the camera around the z-axis, and we show the tilt, and we show the range as well. So the range here is the option we show the distance from the look at position to the point of interest. So the point element here were integrated in the play mark element, or we can say that's a sub element of the play mark, is specify the location of Eiffel Tower using the coordinate of the Eiffel Tower. So to sum up, this example set the virtual camera to be above and looking at the Eiffel Tower with the rotation of 45 degrees lopswise to the from the north, and a tilt of 60 degrees, the range of 500 units distant from look at position to the point of interest. In the left pictures, we see how the look at element is used. The range, so the distance from the eyes, and we have tilt, and we also have the latitude, longitude, and the altitudes of the point you want to set the camera on. In this example, we will take a look at the camera element. The camera element is considered as a similar tools or similar element with the look at element we just talked about. And this camera element in KML used to define the viewpoint for the virtual camera. Instead of defining a viewpoint that looks at the specific location, the camera set the viewpoint as if the camera were located at a specific positions with a specific orientation. So in this example, the camera is used to set the virtual camera at the location near the Leaning Tower, Pisa, with a rotation of 180 degrees, a tilt of 45 degrees, and no roll. You can as well adjust the parameters from the code were given here to change the viewpoint. And in summary, look at is used for dynamic views that can be adjusted to look at different points of interest, while camera elements is used for fixed position views with a static perspective. And both elements are essential for controlling the viewer viewpoint and creating engaging visualization in KML application like Google Earth. So in KMLs, when we browse the KML file in geospatial browsers, a linear or a line is normally called a path. So a path is created by a line strings element. A line strings in KML represent a series of connected line segments, and is defined using line strings command or line string elements, and the coordinates of the vertices are specified within the coordinate elements. You will see here, for example, when we want to show the path from Ho Chi Minh City to Hanoi, via some vertices, some points, so they are the city in betweens. We can use the line strings inside the playmarks element. So the line string here is the child of the playmarks element. And to define the line strings, we can use the coordinates of its cities to connect all of them, and therefore we will have one. At the result, we have one path in the output, and we can view it in the geospatial browser. Here's the Google Earth. And similar to the path, we can have the others objects or the others features in KML. The next one I want to show you is the polygons. When you want to draw a polygon, we use the polygon element, and it will define the polygonal shapes on the Earth surface. To draw a polygon, we just define the coordinate from the start point, and we input the next point of the polygons. So the last coordinates of the last point will be the same with the first one. We will go to the next slide to take a look at one specific example. Here in this case, we have one KML code. When displayed in the KML viewer, it shows a 3D extrude polygon representing the pentagon with an outer boundary and the inner boundary. And the altitude for all vertices is set to 100 meters relative to the route. The coordinates in the coordinate element define the specific point that make up the pentagon and its horn. We will take a look. Here is the altitude as well as the height of the injection. And in the altitude mode, we set to relative to route, and we also set one element extrude to 1. This means that this will be extruded to the outer space. And you can see here, when you want to define the polygon, the first point will be exactly the same with the last point given here. So therefore it will make a close polyline. Yes, for example, this is the 1, 2, 3, 4, and the 5th out of the point number 5, and we input again this point. Yeah, so this will close the polygon. So you can see with this KML, and we view it in the browsers, we will see one polygon in the shape of a 3D element, 3D objects. Now we look into the style in KML. First, style and ID definitions. In KML, we have the style, which define the visual appearance of graphic features such as points, lines, polygons, and overlays. And these styles are identified by the unit IDs. When a style and ID are defined, they can be applied to various elements in the KML file, including geometries, plane marks, and overlays. This allows for consistencies in visual representations across different parts of the KML file. The second thing is the style, the shared style. The style can be shared and reused throughout the KML files, as I introduced. This means that a single style definition can be referenced multiple times by different features. So how can we do it when we want to reference a shared style? We just use the tag style URL here, and the name of the style word defined now will be add with a sharp side, and the sharp side now will say, okay, now I want to apply the style I defined before in advance to my features or my objects. The third one is internal style definition. If the style definition is located in an internal file, such as a separate KML file or KMZ archive, the complete URL to the internal file is included in the style URL element. So this allows KML file to reference style defined in internal sources, enhancing modularities and reusability. Lastly, document element. The document element serves as the container for features and style within the KML file. Therefore, it's required when shared style is used. By encapsulating features and style within a document, the KML file maintains organization and structures, making it easier to manage and maintain. So these are the principles of style in KML. Now we will take a look into one example. Now we have one example to understand the style more better. Our purpose is to set up or to define the style which can be applied to the bed where drawers were made in advance. Now we look at the style definition. We start only with the style ID. So the ID of the style, you can name it. For example, here I name it at my bus style. And inside or the subject elements, we can define lifestyle with color. You can use the code of the color you want. For example, here I choose the red color for the bed, and you can also define the width. How wide it should be, and here I choose 3, mean 3 pixels. So I write a closing tag for the lifestyle, and after that I write a closing tag for the style. So now I finalize my style name, my bus style. Now I want to apply it to the plain marks which were generated before. So this was the code we used to write the pathway. I just insert one line name style URL to reference the style here. And when you use the style URL with the style word defined in advance, please remember to use a sharp symbol at the beginning of the bus style of the style you just generated. After that, we close the tag. We write the closing tag to nest the XML, to nest the KML properly. And now you can import this KML file into Google Earth to have a look and compare the different results. For example, the first default is the Y linear. Here on the left corner. But after we apply the style into the KML file, we can have the different result with the red linear, the red light here. Okay, now we go to the next slide. Finally, I would like to talk a little bit about the KMZ. The KMZ, firstly, the composition of KMZ is essentially a compressed archive that contains primarily the KML files along with all the supporting files. These supporting files can include image, icons, textures, 3D models, and any other resources referenced by the KML files. How KMZ is packaged and compressed. The KMZ is created by compressing the main KML file and its associated resource using a zip compression algorithm. This compression reduces file size and makes it easier to distribute and share. How can we use it and how we distribute the KMZ file? So, once created, the KMZ file can be stored, emailed, or hosted on a web server like any other file. It serves as a convenient way to package and distribute KML content along with its resources. So, how can we unzip and extract the KMZ? To access the content of a KMZ file, it needs to be unzipped using a zipped utilities. So upon unzipping, the main KML file and its supporting files are extracted, restore them to their original format and directory structures. So each file retains its original file name and extension. Lastly, when everything is unzip or extract, the main KML file from the KMZ archive can then be opened and viewed using applications that support KML, such as Google Earth, because Google Earth can interpret the KML file, and Google Earth can render its content such as playmat, path, overlay, and the other graphic features on a virtual globe. So that's it, the basic information of the KMZ file. We have gone through the content of KML in around half an hour. Now, if you have any questions, please contact me. Thank you so much for your attention.